All right, welcome back. We're at 4 day 2, log equations. We're going to be solving log equations. Big shocker there. Okay, now the basic idea behind this is, here we go. Okay, what is the value of x if log base 4 of x equals log base 4 of 7? All right, well, hopefully it's pretty clear that the x value there has got to be 7, because if you got log of something equals log of something else, then those two somethings got to match. All right, so there's that. Okay, so that above example is another demonstration of the one-to-one property that we've used previously, which in this context means kind of what I said, but if log base b of m equals log base b of n, then m must equal n. So again, if log of something equals log of something else, those two somethings have to be equal. All right, now we're never going to have an equation where the bases of the logs aren't equal in this course, because that gets way nastier than anything we are going to deal with. So there it is. Okay, now one thing before I move off of this slide is you might notice the assignment looks a little bit weird because it's got the high numbers first and the lower numbers second. For whatever reason, in my opinion, the book's got the problems organized where the easier ones are later and the harder ones are earlier. And if you do things in the order that you see them listed over to the right, they'll kind of match the order of the notes a little bit better. So anyway, that's why it looks a little bit weird. All right, moving on. Okay, definitely note that in the one-to-one property, neither log has a coefficient, so if you have a coefficient, turn it into an exponent before going any further. Okay, so if I've got an equation such as the one we have here, 2 log x equals log 64. Now again, the logs are the same there, so I'm not going to bother saying them. So here we go. First thing is, again, take that exponent and move it up as a, take the coefficient, move it up as an exponent. And so we've got log base 5 of now x squared equals log base 5 of 64. Okay, so again, I've got log of something equals log of something else, and again, those log bases are the same. So I can kind of throw out the logs and be looking at x squared equals 64. Okay, once we reach that point in this equation, we can certainly square root both sides, and we get ourselves x equals, now don't forget the minus on this, but plus or minus 8. However, looking over here at the side, another little note. Now, keep in mind that according to the definition of a log, we can only take the log of a positive number, so we must throw out any solution that gives a non-positive number inside the log. And I probably should have said this in the original equation, because of course, as you start manipulating equations around, you know, sometimes you can kind of change the initial conditions of the problem. So I'm talking about the original equation. So in this case, if I take that 8 and plug it in, I'm not taking the log of a negative number anywhere. However, if I plug in the negative on that 8 and have a negative 8 in there, my first side becomes 2 times log base 5 of negative 8, and we're not allowed to do that. So we actually do throw out the negative version of this and have x equals just the positive 8, and that's our final answer. Okay, so again, keep in mind, it has to be a number that you plug in and gives you a negative inside one of the logs in the original equation. If that happens, you throw it out and keep anything that's left over. And if that's the only thing that you had to start with, then you might have no solution. All right, so anyway, there's the deal there. Let's move on. Okay, now most of the problems in the assignment, as it says here, will have 3 logs in the equation, and we can drop the logs when we have one log equals another log. Okay, so can we do the same when we have more than 2 logs? Now, here's a true equation to test that out. Okay, log base 2 of 64, now we know that's equal to 6. And okay, log base 2 of 4, that's equal to 2. And then log base 2 of 16 is equal to 4. So certainly 6 equals 2 plus 4 works great. Cool. But if we just drop the logs, notice we get 64 equals 4 plus 16. And that's very, very not true. So basically, we cannot just simply drop the logs when we have 3 or more logs in an equation such as this. Okay, somebody's going to do that in the quiz, and you're going to lose all, or at least close to all the points for the problem, depending on what else you might do in the problem. But that is what I consider a very, very, very bad conceptual error if you do something like that. All right, so please don't. Okay, but fortunately, we have our properties for condensing logs to help us out when we have 3 loggers in an equation. Okay, so I've got natural log of 4x minus 7 minus natural log of 3 equals natural log of x plus 2. Okay, well again, we've got this thing over on the left, which is a subtraction of 2 logs. So if you remember the order of our properties, that's property 2, the quotient property there. So we can turn the left side into the natural log of the quotient of those two things, 4x minus 7 over 3. Okay, and again here, if you want to throw that in parentheses to help separate top and bottom, that's not a horrible idea, but anyway, there it is. And then over here, of course, we got the natural log of x plus 2. That was only a single log, so we didn't need to mess with anything. But again, at this point, now we have log of something equals log of something else. So we can go ahead and drop those logs because it's a single log equals a single log. The second you don't have single log equals single logs, you cannot just drop the logs. Bad things happen. So please don't do it. All right. So at this point we have this. Okay, now for those of you who look at that and say, yuck, I don't like fractions, put the x plus 2 over 1 and cross multiply. Most of our brains like that a little bit better. All right, so one of my crosses is going to give me a 3x plus 6. The other cross gets me a 4x minus 7. And we can solve that pretty quickly. Subtracting x from both sides, 3x from both sides gets me 6 equals x minus 7. Adding 7 to both sides gets me x equals 13. Okay, now again, before I circle that and call it a final answer, I look at that 13 back in the original. And if I take 4 times 13 minus 7, well, that's not going to be negative. And, okay, 3 is just 3, so the second log doesn't matter. And then log of, well, 13 plus 2, I'm pretty sure that's not negative either. So basically we can check that as a good solution and move on with our life. Okay, and of course we could plug that in and actually do all of the working out both sides to check, but I'm sure nobody's going to do that. But it would definitely work. Anyway, here we go. All right, so log of x plus 5 plus log of x plus 8 equals log of x plus 13. Okay, now again, if your impulse is to, say just x plus 5 plus x plus 8 equals x plus 13, you're very, very incorrect. And if you do that on a quiz, you will lose very, very, very large number of points on this problem. All right, but please don't do that. So anyway, here we go. Notice again, we have log plus log. So that's our property number 1. And that allows us to multiply the things inside the log, so to speak, together. And if I FOIL out x plus 5 with x plus 8, that gets me log of x squared plus 13x plus 40. Okay, and on the other side, I've got my log of x plus 13. Okay, now again, I'm at the point where I have single log equals single log, so I can now drop my logs. And once I do that, I have an equation that looks pretty tame, according to some, or relative to some other equations we've seen in this course. Okay, I'm going to subtract the x and the 13 from both sides, and I'll get x squared plus 12x plus 27 equals 0. All right, a little bit of factoring gets me x plus 3, x plus 9, and that gets me x equals negative 3 and negative 9. Now again, I got to make sure that those don't give me negative inside a log in my original. So I check the negative 3, and if I take negative 3 plus 5 for the first term, I'm still good. Negative 3 plus 8 and negative 3 plus 13, that's good all the way around, so I do get to keep the negative 3. Okay, if I check the negative 9, by plugging it into either of the two logs on the left-hand side, I do get log of a negative number of some sort. So I do have to throw out the negative 9. Bad. But I do get to keep the negative 3. So please don't assume that any negative is necessarily bad. It's about whether or not you get a negative when you plug that value into the original problem. That's when it becomes bad. Nothing wrong with having a negative answer as long as it checks out in the original problem. All right. So here we go. Now, to move on with the second half of the assignment, basically, here we go. Okay, we're going to be converting between log and exponential forms of equations. So the definition there, if I've got b greater than 0 and not equal to 1, and then the x value equals 0, y equals log base b of x is the same exact thing as saying b to the y equals x. Okay, now there's no restrictions on y. We talked about that before. Okay, now using that definition, we can translate between log and exponential equations because there are times when one is more useful than the other. For example, actually not for example yet, converting log base 3 of 81 equals 4 into an exponential. Well, okay, we've done this before using that same exact example. We get 3 to the 4th equals 81, which again, it's all numbers, so it's very easy to verify that and check out that what we've done is correct. Of course, once we start sprinkling variables in there, it gets a little harder to verify that what you did is good. So you do need to make sure that you can do it kind of when you're able to check it and get the pattern down so that when you can't check it, you have confidence that you're still good. All right, so moving along, here we go. If we encounter an equation that we're trying to solve and there's a mix of logs and non-logs, we can convert the equation into exponential form if it allows us to more easily isolate the variable. Of course, if it doesn't allow that, then you don't do it and you try to do something else. Okay, but here we go. If I want to solve log base 3 of x plus 7 equals 4, that probably looks very similar to the last one, other than the 81 has now been replaced with x plus 7. Okay, here we go. Okay, we've got ourselves 3 to the 4th equals x plus 7. Again, the base to the number on the other side of the equal sign equals the thing inside the log, so to speak. And there we are. Now, of course, 3 to the 4th isn't nice to work with, but of course, 3 to the 4th is a couple of numbers. One's a base, the other's a power, so we can work it out and get 81 out of that. And if I have 81 equals x plus 7, that's pretty simple to do. Subtract 7 from both sides. We get ourselves x equals 74. Okay, now again, before I call that good in the final answer, I think if I plug 74 back into the original, am I going to have problems? And I'm pretty sure 74 plus 7 is not a negative number, so it means I'm pretty good. Now again, of course, if you notice, 74 plus 7 does give us the 81, which is the exact example we used earlier, so I know that definitely checks out if I go through the trouble of doing all the checking. All right, moving on. Okay, now if we have the sum or difference of logs equal to a regular number, can we just drop the logs in that case? Okay, well, here's a couple of true statements to test. Okay, now again, log base 3 of 81, we already know that's 4. If I have log base 3 of 9, I know that's 2. And if I do 4 minus 2, I definitely get the 2. So again, definitely a true equation. But if I just drop the logs here, 81 minus 9, I'm pretty sure that's not 2. Bad news right there. All right, same thing with the addition. Log base 2 is 64, I know that's 6. Log base 2 of 4, I know that's 2. And 6 plus 2 definitely gives us 8. So I know I'm good there, but by dropping the logs at this point, I'm left with 64 plus 4. And that pretty sure that doesn't equal 8, so another bad news there. So again, we cannot drop the logs, okay, when we have a sum or difference of logs equal to a regular number, as those two examples just showed. Okay, so again, it's one of those very large conceptual errors, as I mentioned earlier in this video, that if you do that, it will cost you a large number of points, so please don't do that. All right, here we go. Of course, as you may have guessed already, our condensing properties will definitely help us out. All right, log base 6 of x minus 1 plus log base 6 of x plus 4 equals 1. All right, so again, we have a sum or a difference of logs, in this case a sum, so I want to go hit that thing with property number 1. And notice here FOIL will be involved, so log base 6 of, FOILing that out, I get myself an x squared. Okay, I get a minus 1x and a plus 4x, so ultimately it's a plus 3x. And then I've got myself a minus 4, and then that's going to be equal to 1. Now we can convert that into a exponential form because, again, I'm kind of stuck inside the log, but converting it to exponential kind of gets my variables outside of the log. It gives me something easier to work with. All right, so the base 6 goes to the number on the other side, power, which is 1 in this case, equals the x squared plus 3x minus 4. Okay, now admittedly this isn't that dramatic of a step here that I'm about to do, but 6 to the first, well, that's just 6. And then I'm going to leave the other side alone for just a sec. Okay, at this point I can subtract 6 from both sides because, of course, if I have a quadratic, most methods for solving that involve getting a 0 on one side, so let's make sure we do that. And I'm left with x squared plus 3x minus 10 on the other side. Okay, that's definitely factorable. And so let's go ahead and do that. And hint, the problems in the assignment that work like this will be factorable. If you can't get it to factor, that means you probably made some kind of mistake someplace, so check your work. All right, but anyway, here we go. We get x minus 2 and an x plus 5 out of the deal. And so ultimately we get x equals 2 and negative 5. Now, of course, again, we want to check and make sure that both of those, or both solutions, give me positive inside all of my logs. Otherwise, I throw them out. If I plug in the 2, I get 2 minus 1 and 2 plus 4 inside my logs, and those both give positive results, so that's good. However, that negative 5 and negative 5 minus 1 and negative 5 plus 4 both give negative results, so we do have to throw out the negative 5, and we're left with a single answer, x equals 2 in this case. All right, a little more here. Okay, what if we get a subtraction? Log base 5 of x minus 5 minus log base 5 of x plus 7 equals 2. Okay, well, again, I've got a subtraction right there between two logs, so first thing I want to do here is use my property number 2. I can go ahead and turn that into a log of a division, or a quotient, if you want to say that, fancier word. So log base 5 of x minus 5 over x plus 7. Okay, now again, if your handwriting is a little bit like mine, and that 5 that's the base looks like it might be part of that x plus 7 on the bottom, definitely throw some parentheses around there and avoid that circumstance. And we've got that thing equal to 2. Okay, but now I've got a logarithmic equation, which is a single log equals a number, so I can convert that into an exponential form. And so in this case, I get 5 to the second equals x minus 5 over x plus 7. Okay, and of course that 5 to the second can become a 25. And that gives me something that's a little more user-friendly to look at. Okay, now again, since I do have a fraction on the one side, I probably want to think of that as a cross multiplication situation. And if I do that, I get myself a 25x plus. Now, if you're going, oh my gosh, I can't do 25 times 7 in my head. Well, if I handed you 7 quarters, I bet you could tell me what you had. That'd be $1.75. Okay, so if you're reaching for a calculator on something like that, then shame on you. But anyway, there we go. Okay, I'm a little light on room here, so let me do 2 steps at once. I'm going to subtract x from both sides and subtract the 175 from both sides as well. All right, and that's going to get me a 24x equals, okay, in this case, a negative 180. Okay, now one thing that I'm pretty sure about here, well, actually, let's do this. I get negative, it's going to be something. Whatever 180 divided by 24 is, let's go ahead and divide by 3, and I get 8, and I get 60. I can then divide by 4, and I get 2 and 15. Pardon me for talking through this, but then that works out to be negative 7.5. Okay, of course, use your calculator if you want to. All right, so, or reduce if you like. Anyway, I get negative 7.5 there. Now, clearly negative 7.5, if I plug that into the x minus 5 in my first term, or even into the x plus 7 in my second term, notice both of those result in a negative answer. So basically, I have to throw that out. And notice I'm throwing out my one and only solution I had. So here's the case that I kind of alluded to earlier, that we actually have no solution. Pardon the extra dot there around the solution. Boom. All right. So that definitely is a possibility, and that was the last example. So just be aware of that. But again, they're very important to check your solutions, because some of them will be good, some of them will be bad. But again, not necessarily all negative ones are bad, as we saw in one of the previous problems. So again, don't go assuming that they're bad just because they're negative. All right, but anyway, hopefully that all made sense. As always, I will gladly clarify anything in class that didn't quite make sense, and I will see you there in class.